Hi, welcome back to my No BS gear review channel. What you're seeing beside me on the screen is a chunk of titanium being machined. I would like you to see how fast this cutter moving and chewing through titanium. I mean, they go on full depth. But wait a second, we were told that titanium is extremely difficult to machine. Well, the truth of the matter is, it was difficult to machine years ago. Titanium in itself is not a very hard metal. It's a very viscous metal, and it does weirdest things when it heats up. So the key to the titanium machining is proper balance between the feed, in other words, how fast the tool head is moving, versus the speed of rotation of the mill. When you dial it all in, titanium is not any harder than anything else. So there are a couple myths that I'm going to try to bust here. Myth number one is that integral knife construction is a very innovative recent development. That is incorrect. Integral construction existed ever since the folding knives came to be. These knives were made all throughout Europe. This particular one is from Portugal. Here you have a staghorn, which is solid. There are no two halves. And it's slotted, and therefore it's an integral folder. So this construction has been around from early 18th century. This knife was made in the late 80s in a Soviet or Russian prison. And as you can see, it's not all in one piece, but you can see that the handle is one piece. It's integral handle. Actually, this is an automatic knife, which is lacking a push button and a stop pin that was also mounted on the blade. Another feature that's been around for a long time. And I'm almost certain that in this case, they used a hand grinder. So basically, somebody had a handheld grinder, put it in a vise, and came in and cut themselves a slot. The next myth I'd like to bust is that it is more labor intensive somehow to build an integral knife as compared to a traditional slab side construction. This construction actually requires more machining operation than this construction. Firstly, you have to cut each slab individually. This handle cut out of much thicker plate or sheet of titanium, but you only need to cut out one profile, and while a little slower, it still will take less time overall than cutting two profiles. When you set it up in the block, you can clamp it into the vise. They probably used a carbide tooth cutter, so it came in and cut the slot in here. I can look in there and actually see that after they did that, they came in with an end mill and machined the slot a little deeper, and you can see where the mill exited the cut toward the front right there. Pretty straightforward procedure, if you ask me, and a lot less challenging to clamp the handle in a vise like this on the machine than grind these parallel on a grinder. Why is it hard to grind these parallel? So for any knife to work properly, any folder, any flipping knife to flip properly, especially in the pivot area, these two slabs of metal have to be very much parallel. Otherwise, at some point in its rotation, the blade will bind, even if it is running on bearings. And I'm sure you've experienced that on some of the more budget knives or less expensive knives, where you feel like it binds a little bit toward in one or two spots during rotation. And that is because the parallelity between the two surfaces, inner surfaces, was not achieved. A key to parallelity, other than the actual plates being perfectly flat and have parallel sides, is how parallel are the spacers. In my days as an industrial engineer, we would charge not only by the machining time, but also number of setups. Titanium being non-magnetic exacerbates the difficulty of setup. You know, when you're milling something, that workpiece has to be absolutely immobile, as in no movement, no vibration of any kind, or you will screw it up. A lot easier to clamp like this than clamp flat like that. So they also have to drill pretty accurate holes here And especially around the pivot, the tolerances are super tight. And Kunwu does actually a good job. I'm glad I'm using it as an example. Chris Reeve is another example. Even Medford puts a lot of effort into properly machining their pivot holes and making their slabs parallel. So that's where the major challenge lies. So many operations, a lot of setups on the mill, flipping it over to do the lightning passes there with the hand mill again. So a lot of work goes into this construction. So now you know that when a YouTuber says it's easier to machine or construct a sandwich-built traditional flipper compared to the integral, it's a busted myth. So the fair question is, why are integral knives so expensive? Is it the material, perhaps? For a manufacturer to buy titanium, they have to pay per plate. And these plates come in different sizes. Let's say if I wanted to make 7 handles out of a grade 5 titanium, that's what the comparative cost would be. Integral construction on the top and slab construction on the bottom. These are retail prices, of course, but in general it shows that there's only 10% difference in the material cost between the two methods. Why is it? It's because the mill that made the bars or the plates of titanium also charges overhead cost, handling, carrying fees, etc. So each plate or bar of titanium that goes into the knife production comes with this built-in cost, and it's not linearly proportionate to the thickness. So anyone watching with a first-hand knowledge of purchasing titanium plates for production, please comment. Let me know if I got anything wrong in this segment. I believe everyone would like to know. There is another myth. It is more difficult to disassemble and maintain integral knives. That is just not true. Let me show you how easy it is actually to assemble this knife, at least this particular model. And this is where I applaud Kunwu engineers for designing this unit with manufacturability in mind. Bravo! So you just saw me in 20 seconds or less putting together blade, first bearing, pivot, and now I'm putting the second bearing, the spacer that has to go between the bearing and this Damascus insert, and now I'm just putting the screw. That's how easy that is. And then because the interior is so smooth and there are no sharp corners in there, all I had to do is blow through it, and I believe this is grade 5 or 6 titanium. There's no fear of corrosion between it, DLC coating, a very stainless blade, and a DLC coating on it. So there's absolutely no difficulty here with maintainability. But if you are complaining about the price of integral knives, you are correct. Technically, if the production numbers were equal between traditional construction sandwich and integral construction, if the numbers were equal, then the cost should be lower making integral knives. For a frame lock, the most cost prohibitive production is for the type that is a sandwich construction with lining cuts on the underside of the frame and a solid elongated backspacer. I'm going to make a detour and use these Medfords to illustrate my example. This is Marauder Slim Midi, and it has machined or lathed spacers. These are much easier to make than the plates that I was talking about, the spacer plates, because on a lathe you control the perpendicularity between this side and this side very easily, so much less of effort goes into making these than something like that. I'll get to it in a second. Anyway, the price for this knife is in the 500s. So when you go to a steel backspacer, which has to be milled and then ground to size, the price goes up a little bit because this grinding is an extra step that you have to do. But with steel, it's magnetic, so you can clamp it to a traditional back and forth grinding machine, magnetic tables are on all of them, and it'll stay there as you grind it. You just have to flip it over. Pretty straightforward operation here. So the price does, however, jump into mid 700s to mid 800s, but related more to other things on the knife. Here is a knife that actually has a slightly easier, I would speculate, to fabricate the blade on this knife, but the price jumps another $100 because now they are grinding this titanium spacer, and you can only grind titanium on a certain types of the machines unless you can figure out a way to bolt it down because it's non-magnetic. And Greg in his factory tour, Greg Medford, showed the specialized humongous flat grinding machine that they have. So that bumps the price by $100. And now when you get into a lot of thickness ground titanium parts and a larger pieces of titanium, you get into really big bucks. This is $1,200-ish knife. But I can totally see the production cost jumping by that much from here to here. I mean, this is a huge knife. Look, it thwarts the Excalibur. Right. Help it. Yeah. I knew this reminds me of something else. Yeah. Well, I'll be. So another myth I'd like to bust today is that somehow I financially benefit from bashing this brand. I am not bashing it. I am showing you my findings, right? And when you come after me and yell in the comments, you're just showing how little understanding you have about technical aspects that I'm presenting. There's not actually any way for me to recover the money that I put into this channel unless I start actually selling you knives, which I will not do ever, right? I don't do that. You know, a traditional knife reviewer would be at this point saying, well, this knife is great, but it's overpriced, so how about you try this knife right there, you know, and give you an affiliate link. Dickey did it, Neves does it, and other reviewers do it too. So, speaking of Neves, the offender is on its way, so there'll be a video or 2 or 3 about that too.